problem. Y double prime is equal to y prime squared. So the first thing we do is to let y prime equals v. So we have here v prime is equal to v squared. Cancel this. We have y dv over dy is equal to v. dv over v is equal to dy over y. Integrating both sides, we get ln of v equals ln of y plus c. So we can write this one, ln of v is equals to ln of y plus ln of c. Therefore, v equals e to the ln y times e c1. So y prime equals y c1. dy over dx equals y c1. We have dy over y is equal to c1 dx. Integrating both sides, we have ln of y equals c1x plus c2. Y therefore is equal to e c1x times e c2. Thus, we get y equals e to the c1x plus c2. This is now our final answer.
So we have the next equation. Clearly, it is a separable first order equation. So since it is separable, we have to separate all the variables, different variables. So we have x times y squared plus 3y dx equals dy. X dx is equal to dy over y squared plus 3y. Integrating both sides, we get x squared over 2, and this we have to use partial fractions. So using partial fractions, we have dy over y times y plus 3. So we have 1 over y times y plus 3 equals a over y plus b over y plus c. We have 1 equals a times y plus 3 plus b y. So 1 equals ay plus 3a plus by. So we have 1 is equal to 3a and a plus b is equal to 0. You might wonder why we have this. It is in the partial fraction law, or somehow in the rules of partial fractions, that we get 1 equals to 3a and a plus b equals to 0. So it's understandable. We have a is equal to 1/3, and then substituting a through this, we have b equal to negative 1/3. So we have the result for a and b. So we can now integrate this. dy over y squared plus 3y equals 1/3 of 1 over y dy minus 1/3 of 1 over y plus 3 dy. So we get 1/3 ln of y minus 1/3 ln of y plus 3 plus ln of c. So combining the first integration, we have x squared over 2 is equal to 1/3 ln, combine these three terms, ln of y over y plus 3 times c. So we multiply this one by 3. We have 3x squared over 3 equals ln of y over y plus 3 times c. So this is e to the 3x squared over 2 is equal to e to the ln of y over y plus 3 times c. You have e 3x squared over 2 is equal to y over y plus 3 times c. Thus, y is equal to y plus 3 c times y plus 3 times e to the power of 3x squared over 2. This is now the final answer. So this is our third equation. By inspection, you can see that it is a linear differentiation. So we can write this one as x dy over dx plus 1 plus x times y equals e to the negative x. So in order for this to become a standard, to form into a standard, to its standard, we have to multiply this one by 1 over x. So we get dy over dx plus 1 plus x over x times y equal to e to the negative x over x. So in linear differentiation, the first thing we do is to get the integrating factor. So getting the integrating factor v is equal to e integral of this, the px 1 plus x over x dx. So this is v equals e to the negative x times x. So this is now our integrating factor. Now when we have our integrating factor, we have to multiply this one to our standard form. So we have 3y over dx plus 1 plus x over x times y equals e to the negative x over x times, multiplying both sides by e to the x times x. So we have e to the x dy over dx plus e to the x times 1 plus x times y equal to 1. It is in the linear differentiation rule that after multiplying the integrating factor, in order to simplify this, the left side, we have to integrate dy over dx by multiplying the integrating factor and also the dependent variable. So we have our integrating factor is this one, e to the x times x, and multiply by our dependent variable, which is y, times y is equal to 1 dx. So we have x e to the x times y is equal to x plus c. Thus, we can have y is equal to x plus c over x e to the x. So, we simplify, we can get y is equal to e to the negative x times x plus c over x. So, this is now our final answer. So, it's quite easy, right?
So this is now our fourth equation. So clearly it is a homogeneous equation. So we have to let y equals ux. So dy equals u dx plus x du. Substituting this one from this equation, we have u dx plus x du all over dx equals x plus 2y over y plus 2x. We have y plus 2x times u dx plus x du equals x plus 2y dx. So after distributing, we have xu squared dx plus ux squared du plus 2ux dx plus 2x squared du equals x dx plus 2ux dx. So we cancel this one, this and here, and also that would be all. So we have x u squared dx minus x dx equals negative 2x squared du minus ux squared du. So we have x times u squared minus 1 dx equals negative x squared 2 plus u du. Then we have negative dx over x is equal to 2 plus u du all over u squared minus 1. Integrating both sides, we get negative ln of x. And the right side, we need to use partial fractions to integrate this. So we do the partial fractions and we get 2 plus u over u plus 1 times u minus 1 equals a over u plus 1 plus b over u minus 1. Therefore, 2 plus u equals au minus a plus bu plus b. U plus 2 equals a plus b times u plus b minus a. A plus b therefore is equal to 1. B minus a is equal to 2. Therefore, we get a equals negative 1/2 and b equals 3/2. So after the partial fraction, we get the value of a, which is 1/2, and then b. So we continue with negative ln x equals negative 1/2 ln of u plus 1 minus 3/2 ln u minus 1 plus c. Ln of x equals 1/2 ln u plus 1 plus 3/2 ln u minus 1 plus c. So x therefore equals u plus 1 to the power of 1/2 times x minus 1 to the power of 3/2. X squared equals u plus 1 times u minus 1 cubed times c. X squared equals y over x plus x times y minus x over x cubed times c. So we have x squared equals y plus x times y minus x cubed times c over x to the fourth. And then we get the final answer, which is x to the power of 6 equals y plus x times y minus x cubed times c. So in order to solve the problem, we have to let P sub O be the initial amount, small p as our rate, delta t as our time elapsed. And then we have amount equals to P sub O times our rate times delta t. So our new p here at any time t equals P sub O plus our amount. So we have P equals to P sub O plus P sub O times P delta T. And then we get P equals P sub O times 1 plus P over 100 delta T. We can put P over 100 here because P is just a percent. It is in the compounded interest law that dP over dt is just proportional to our P. So we have dP over dt equals Kp, where K is our rate. dP over P equals K dt. Integrating both sides, we have ln P equals KT plus C. At time t equals 0, we have ln P sub O equals C. So we can write ln P minus ln P sub O equals KT. So we have here P equals P sub O e to the KT. So we have P equals P sub O e to the pt. And then we can get P equals P sub O e to the power of P over 100 times t. That's our final